Okay, this is a video about another integration technique, partial fractions and long division. And it has to do with rational expressions. And there'll be some different things that we always still go through, our common things that we think about first to see what we're going to do. And then this is going to be another technique that might come up for us to solve. So these are just 3 examples of, or actually 4, I guess, 4 different kind of things that you might see. You're always going to go through first, is it a formula? And if you look at this one right here for a moment, you might think it's a formula because it's almost like arctangent, but it's the -1 that messes us up. So it's not a formula. And then we would always look for u substitution to see if we could do a du over u since we have dividing. Well, if we look at this one, we can actually do du over u, so we can just do u substitution. Because if we were to let the bottom be u, the x squared minus 7x minus 10, then the derivative would be 2x minus 7 dx. And so we could actually just do u substitution. But these 3 down here, none of them fit a formula, and none of them would be du over u. And so we're going to need another way to figure that out. So we're going to sometimes use something called partial fraction decomposition. So the important time to know that you might be able to use it, because again, I have to have a process. Okay, is it a formula? Can I make it du over u? If it's not, okay, it's rational. So is it what we call a proper rational expression? That just means that the degree of the numerator is less than the degree of the denominator. If it is, then we're going to try maybe partial fractions next. If it's not, if it's what's called an improper rational expression, simply means that the degree of the numerator is greater than the degree of the denominator, then we will try long division to see if we can get it in a form so that it's a proper rational expression. So this is the one we were just looking at that I said kind of looks like arctangent. Well, it can actually be written as -1 over x plus 1 plus 1 over x minus 1. This part on the right, where it has the plus, is the partial fraction decomposition. So basically, it's like unadding, okay? So putting it back to an addition problem. Well, it's not that simple that you can just do it real fast, but we do have a process that works, and it's not that difficult to do, but we certainly can't just see it that easily. So, the denominator needs to be something that's a product of distinct linear factors. So the sum of the partial fractions will all be some constant a, some number over ax plus b, some linear factor on the bottom. Now, in later calculus classes, you may need to look up and figure out how to do it if the bottom are not linear factors. For example, if the bottom had a non-reducible quadratic in it, then there's another way to do that, or if you have a repeated linear factor. So we're only going to do the ones that have non-repeating linear factors, okay? It's not very difficult to add to do the other ones, and so if you need it later, you would just look it up. It's a nice thing about this day and age. You can just type in partial fractions for integration, and you can find plenty of things to do that. We're going to focus on what's going to be on the BC exam. So basically, what we're going to do is you're going to take a problem, and you're going to factor the bottom, and then we're going to write the right-hand side as a sum of linear, of factors that have the a and the b. I don't know the numerator, and I'm going to have each of those factors as a denominator, and then we're going to solve for those things. So here we're going to do this method all the way through. Again, it's super easy. So it just needs practice. So first thing we would always do is look at the problem and say, is this a formula that I know? Do I already know how to integrate it? And it is not. And then I would look to see, okay, I'd say it's a quotient, so could it be du over u? And it's clearly not. So since the bottom is a polynomial that can be factored, I'm going to do partial fraction decomposition. So over in my scratch area where I do my scratch work, I'm going to write 1 over x squared minus 4. Well, actually, instead of writing it like that, let's just go ahead and factor it. So it's x minus 2, x plus 2. That makes it quicker. If you need to do the factoring with some help, just do that in another area. So I write it already factored. So it's 1 over x plus 2, or x minus 2 times x plus 2. So then I write a over x minus 2 plus b over x plus 2. Now, if I switch the order of the factors on the bottom but leave a and b the way they are, I'm going to get a different a and b. So don't confuse yourself if you're working with someone and they got different answers for a and b. It matters what factor they're above. So that has to be the same, but not necessarily what you picked for a and what you picked for b. So now what we're going to do is we're going to basically multiply. So we'll skip this step in future ones, but right now I'm going to show it. We're going to multiply both sides by the least common denominator to get rid of the denominators. Well, the least common denominator has to be this one on this side because that's literally how I made up this right-hand side. So that's going to be my least common denominator. The reason we do that is so that we get rid of these denominators and it leaves us something we can solve. So we get that 1 equals a times x plus 2 plus b times x minus 2. Because in the future it'll be easy, once you do enough of them, you realize that the right-hand side is just the factors you have on the left. You can just realize that you'll just be multiplying by the one that's left over. Then we know that this is true, and so we're going true for all x, so we pick any x's that we want. And so I'm going to pick x's that make life easier. So I'm going to, on the first time, let x equal negative 2. So that means that 1 would equal a times 0. That's why I picked negative 2 plus b times negative 4. So I'll get that 1 equals negative 4b, so b equals negative 1/4. And I'm going to do the same thing, and I'll do it a little quicker. And the way we'll normally do it, I'm going to let x equal 2, which will make the second factor 0. So I'll get 1 equals 4a, because when I plug 2 in here, of course, I'll get 0. So that means a is 1/4. So what that means is this integral is the same thing as, I'm going to put my a right here and my b right there and write it over here. That 1 over x squared minus 4 is the same thing as 1/4 over x minus 2 plus negative 1/4 over x plus 2 dx. Now, normally we would go straight to this step. I'm going to write it 1/4 times 1 over x minus 2 minus 1/4 times 1 over x plus 2, so I'm not having to deal with a fraction over a fraction. Now, you also could have put 1/4 all the way in front because it happened to be the same, but I'm going to leave it right here and just answer this. So very often, or in our case, really every time, most every time, or every time, you're going to end up with this being an ln situation because the bottom are going to be linear factors and the top's going to be a constant. So the first one, leave the 1/4 alone, and then when you integrate 1 over x minus 2, you get ln absolute value x minus 2 minus 1/4 ln absolute value x plus 2 plus c. And so there is my final answer. So you're going to normally end up with ln situations that end up being really easy to integrate. Now, if I'm on a multiple choice test, let's think about some things that might happen here. So what if I factored out 1/4 and did ln of absolute value of x minus 2 minus ln absolute value of x plus 2, and then you still have your plus c here. Well, then it could be 1/4 ln, I'm subtracting, so it could be absolute value of x minus 2 over absolute value of x plus 2 plus c. So, you know, again, keep in mind, you've got to know those properties of logs because often problems have things simplified using those properties. Okay, so let's go to this one. So first step, is this a formula that we know? Certainly we do not have a formula that looks like that, so we do not know this one. Then we would look, okay, it's a quotient, so can I do du over u? But if u is x squared minus 7x plus 10, you're going to get 2x minus 7, which is not what you have on the top. So we're going to do partial fraction decomposition. So we go to the side and we write x minus 11 over and go ahead and factor the bottom as you copy it over. So we have factors of 10 that add to negative 7. So that's going to be x minus 2, x minus 5. Then doesn't matter what's on the numerator over there. We're always going to write it as a over one of the factors plus b over the other factor. And then instead of actually physically multiplying like I did on the last one, just know I'm going to multiply by x minus 2 times x minus 5. So the left is going to be x minus 11. The right will be a times x minus 5 plus b times x minus 2, because that's what's going to be left if I multiply by that common denominator. So then I'm going to substitute for what is going to make one of the factors 0, so that way I can solve. So the first thing I want to do is let x equal 5. If x is 5, don't forget the left-hand side has something now. So if x is 5, we're going to get 5 minus 11, which is negative 6. This term will be 0 because 5 minus 5 is 0. So you'll have 5 minus 2, which is 3. So you'll have 3b. So b equals negative 2. So I've now found out what b is. And then I'm going to let now x equal 2 because that will make 0. So I will have 2 minus 11, which is negative 9, equals negative 3a. So a is 3. So now that I have that, we go back to our original problem, and we're going to rewrite. So I'm going to make this in red so you can see better what we're doing. So I'm just going to substitute a and b right in here, the ones that I just found, and write that whole side to over here. So I have 3 over x minus 2 because a is 3. And I'm going to go ahead and put minus since it's a negative 2 over x minus 5, and then this whole thing dx. So now all I have to do is integrate them. So I have 3 is a constant, so you can leave it out in front, and then it's 1 over x minus 2, integrate that, ln absolute value of x minus 2, minus 2, ln absolute value of x minus 5, plus c. And again, many different things could be done to check the answer. I would just always leave my answer like this. And then if you need to match it, you'll have to use some log properties and work on that. Okay, so next example. So same process. First we look, does this fit a formula? And it does not. We look for a u substitution, and you will see that it will not because you'll get 2x plus 3, and the top cannot be 2x plus 3, so it's not going to work. So we're going to go to the side in our scratch area and do partial fraction decomposition. So the top you leave alone, and the bottom you factor. So this time you're just factoring out x, and then you have x plus 3, and that's going to equal a over x plus b over x plus 3. Then you're going to let x equal whatever is, or then we got to multiply by that common denominator. So basically we get 3x plus 6 equals a times x plus 3 plus b times x. Now you're going to do whatever you need to make zeros for those factors on the right. So the first time I'm going to do x equal negative 3. So that's going to give me negative 9 plus 6. So negative 3 equals negative 3b. So b is 1. And then I'm going to let x equal 0. So I'm going to get 6 equals 3a. So a equals 2. Then we go back over here and we're going to fill in. So we have now just rewritten this whole thing as that partial fraction decomposition 2 over x, because we had a over x, plus b, which is 1 over x plus 3 dx. Then we do the antiderivatives. That's 2 ln absolute value of x plus ln absolute value of x plus 3 plus c. Be sure on your homework you're always doing those absolute values, because now you're very unlikely to forget that. You know, we do this enough times. Okay, so let's go to this next example. So again, we're going to go through the process. It does not fit a formula, so clearly that's not the case. It's not going to be U substitution. You should be able to see that pretty quickly. So we're going to do partial fraction decomposition. So the top you leave alone. The bottom you're going to factor. Well, to factor the bottom, I'm actually going to kind of go down here to this little spot because I might need a little, it's more than one step. So I'm going to factor out x, and then I'll be left with x squared minus 4. And then, of course, x squared minus 4, x minus 2, x plus 2. So that's what's going to be here. So this time you're going to have an a, b, and a c. Same process, doesn't matter. A over x plus b over x minus 2 plus c over x plus 2. And then we just keep letting x be whatever it's going to take to get rid of stuff. Or no, I guess we got to write. Sorry, got to write it first. So we have x squared plus 12x plus 12 is a times, well, this time you have x minus 2 times x plus 2 left. And I'm not going to have room, so we'll have to, I'll put that integral on another page. Because this time you have 2 factors left that you cannot get rid of for each of these. And I ran out of room here. C times x times x minus 2. All right, so we're going to go through same process. So first we're going to let x equal 2. I just picked that first because it's the first one I saw. So you'd have 4 plus 24 is 28 plus 12, so that's 40 equals, you put 2 here, you're going to get 0. That's why I picked it. And 2 here is also going to get 0. So that helps a little bit. So we get 2 times 4, that's going to be 8b. So b is going to equal 5. Then we're going to do same thing. Let's let x equal negative 2. So that's going to be 4 minus 24. So that's negative 20 plus 12. So that will be negative 8. And then when I put negative 2 in, the first 2 will be 0. So only c will be left. That'll be negative 2 times negative 4. That's 8c. So c is negative 1. And then I need to do the last where I let x equal 0, which will get rid of the b and the c parts. So I'll get 12 equals negative 2 times 2, negative 4a. So a is negative 3. So there are my values. So let me extend the page here. Well, I'm ready to go to a new page. Let me add a page real quick. So my integral, original problem, I'll rewrite that. An it is now equal to, if you look at your notes, you will see that I have a over x, and I found a to be -3. So that means I will have -3 over x plus, my next term was b over x minus 2. We found b is 5. So that's going to be 5 over x minus 2 plus, and my last term is c over x plus 2, and c in my case is -1. So I get -1 over x plus 2. Again, you could have put the factors in different order, then your a, b, and c would be different. You still have to end up with the same number over each of the bottom parts, but you might not have literally a, b, and c the same because they're just arbitrary things that you picked. Now we're just going to do our antiderivatives, so that's -3 ln absolute value of x plus 5 ln absolute value of x minus 2 minus ln absolute value of x plus 2 plus c. And then again, could be all kinds of things done with those properties to combine those, things like that. So just make sure you practice those properties. So we're going to start the long division section, and then we will finish the notes in class. So if the top has a factor, it had a degree bigger than the bottom, we need to do division. Well, for this very first example, we actually can do synthetic division because the bottom is x plus 4. So remember, you can use synthetic division when you have a linear factor that has a 1 in front. So I'm going to do synthetic division so that we can refresh on that too, and then I'll also do long division on problems. So to do synthetic, inside we write the coefficients of each of the x terms, making sure we cover them all. So I have 3x cubed, 8x squared, -10x, and 15. And don't forget, if we had been missing one of those x's, we would need to put a 0 there. And then remember, outside for synthetic division is the 0. So -4 plus 4 makes 0. That's what we put outside. So you can think of it however you want. It's the opposite, whatever. So synthetic division, we bring down the 3, and then we multiply 3 times -4, put it in the next column, and then we add. So we get -4, we multiply, we get 16, we add, we multiply, we get -24, and then we add, and we get -9, and that's the remainder. So now we will rewrite the problem as what I got for the quotient plus remainder. So remember, this is the remainder. So this is the constant. This is the x to the first, and this is the x squared. So I got 3x squared minus 4x plus 6 minus, and remember, we do the remainder over the divisor, which was x plus 4. So this is going to be important stuff to remember because you're going to need that for even with long division. You're going to have to remember that you write the remainder over the divisor. Now I simply find all the antiderivatives because now everything is something I know how to do. So this is x cubed minus 2x squared plus 6x minus 9 ln absolute value of x plus 4 plus c. And you should get really quick at those ln's now. All right, so example 6 is going to be long division. And if you don't have room to write these, make sure you grab a piece of paper. So you might hit pause and grab paper so that you can make sure you have room to do this. This is a short long division problem, but the other ones are going to be a little longer. So here, again, I have the power on top the same as the power on the bottom. So I'm going to do long division to do this question. As long as the top degree is the same, is greater than or equal to the bottom, you can use long division. So we'll do long division here. It'll be really easy. It's really short. We're going to divide x minus 5. Oh, goodness. sorry, x minus 5 is divided by 2x minus 2. I started to think about partial fractions and write the 2x minus 2 first. So 2x minus 2 into x minus 5. So what we do, remember, is how many times does 2x go into x? In other words, 2x times what gives me exactly x, and that would be 1/2. 1/2 times, then you multiply. 1/2 times 2x is x. 1/2 times -2 is -1. Draw the line, change the signs. That's how we do subtraction for polynomials. I get -4. So then I'm done, because that's the remainder. So my answer is that this integral is equal to the quotient, which is 1/2, plus, or in this case, minus the remainder over the divisor. Okay, so I was able to do division here to get the answer very quickly. And then again, this is super easy to integrate. I get 1/2 x. Now here, be careful when you do your ln. So I would probably reduce this first. And even if you just do it right here lightly, you're going to divide each of those by 2. As long as you divide everything, so you really have 2 over x minus 1. You might want to write that so it's a little easier to see. So this is 2 ln absolute value of x minus 1 plus c. And at any point, if you need to do an integral to the side, you just, of course, do it to the side. So I'm going to just do division on this last one, and then we'll be done with this video. So we go through the processes and find out that we cannot do any of these by a formula or use substitution or anything like that. So we're going to do x cubed plus x divided by x minus 1. But remember that it's easier to have all the terms there. So I'm going to put in a 0x squared and then put my x minus 1 outside. You could also do this one by synthetic division. I'm going to go ahead and do long division so you can see what we need to do here. So x times what is x cubed? That's x squared. X squared times x is x cubed. X squared times -1 is minus x squared. That's why we needed that term there, so I have somewhere to line up my like terms. Draw the line, change the signs. So now I have x cubed minus x cubed, of course, goes away. I have 0x squareds plus 1x squared. So that gives me x squared, and then bring down the plus x. And now I do it again. So x times what is x squared? That would be x. X times x is x squared. X times -1 is minus x. And draw the line, change the signs. Now you need to add, and we get 2x. Well, we can keep dividing, so I'm going to go ahead and put a plus 0 there, bring it down. X times what is 2x? That would be 2. So 2 times x is 2x. 2 times -1 is minus 2. Draw the line, change the signs, add, and you get a remainder of 2. So that means that this integral over here is actually equal to the quotient plus the remainder over the divisor. And then again, super easy, x cubed over 3 plus x squared over 2 plus 2x plus 2 ln x minus 1 plus c. Now that part should be super easy. We're really good at those integrals now. We've been working on those for a long time. So I'm going to stop there with this video. We will finish the rest in class, and we will do more division in class. But if you need any more help with that, make sure that you are looking up some extra help, some videos or something on that, so that you can make sure you know how to do long division. If what we do in class is not going to be enough help and this was not enough review. So that's the end of this video on partial fractions.